Hello Math 10 and welcome to your very first flipped lesson. In today's class, we're going to be learning about prime factors. So to start off, what is a factor? Well, do you remember all the way back in junior high and what a factor is? If you remember, a factor is a number that can divide another number. So let's take a look at some examples here. Here it says, state the following factors. So what are the factors of 15? I could have 1, 3, 5, and 15, right? What are the factors of 24? Well, here I could have, an easier way to do this is we could have 2 and 12, do a factor tree. So we could have 3, 4, 2, 2, right? So we look at this, right there we have 2, 3, so we have 1, always 1, 2, we have 3. I could also go 3 times 2, which is 6. I could go 4 times 3, which is 12. I could go 4 times 2, which is 8. And we have 24. Because we also have to include 1 in itself. 1 in itself are always factors. So for the next part here, it says, determine the number of factors for each whole number. Well, this one I have 1 and 3, right? That's the number of factors for each whole number. So there's 2. This next one I have 2 and 5 and 1 and 10. So there's 4. Okay, so this one is 4 whole factors. Now, my next part here is we're going to look at is I have a secret for you. Okay? It says, Mr. Fody has a secret about prime numbers and composite numbers. Can you figure out what it is? So on this side here, I have prime numbers. Okay? On this side here, I have composite numbers. So here's my first example of a prime. Right? Here's my second example of a prime. Here's an example I have of a composite number. Here's my next example of a composite number. Here's another example of a prime. Here's another example of a composite number. Do you think you know what my secret is yet? Here's another example of a prime. Here's another example of a composite number. Another example of a composite number. And, oh, that might have thrown you in for a loop. And then we have that. Interesting. So now, if you think you know my secret, write it down. See if you can figure out what is a prime number, what is a composite number. This is also a review from years before. Okay? So, here we go. Complete the list of prime numbers. Well, prime numbers are numbers that can only be divided by 1 and itself. So we have 2, 5, we have 7, we're going to have 11, we have 13 and 15. Oh, not 15, 13. 15 can be divided by 3 and 5. And we have 17 and 19. Okay? That's it. So our next step here is classify the following numbers as whole numbers as whole prime numbers or composite numbers. Okay? Well, let's take a look at 46. 46, I know it can be divided by 2. So this is automatically a composite because it can be divided by 2. That's a number other than 1 in itself. 37. Well, I can't divide 37 by anything except for 1 in itself, so this one's going to be prime. 39. I look at this, add these together, that equals 12, and I know that can be divided by 3. So this can be divided by 3. So this is a composite number, which will give me 3 and 13. Let's take a look at 101. Well, 101 tried by 2, can't be divided by 2, can't be divided by 3, can't be divided by 5, can't be divided by 7, can't be divided by 11. Well, I'm going to pretty much guess that this one here is prime, and it is prime. Let's look at 103. Same idea, can't be divided by much, so this one also is prime. So these two are composite, this one's prime. So now, let's combine what we know. What do you think a prime factor is? You know what a prime number is, you know what a factor is. What do you think a prime factor is? Well, a prime factor is a number that is prime and is also a factor of a composite number. And that is a prime factor. Okay? So let's state the factors of 12. My factors of 12 are, well, we have 3 and 4, 2 and 2, so we have 1, 2, we have 4, we have 3, we have 4, and then we also have 6, and that's it, and we have 12. There we go. So those are all my factors. Now state the prime factors of 12. Well, only the primes of these, which are 2 and 3. Those are it, okay? Express 12 as a product of primes. Well, we have this, this, and this. So that's 2 multiplied by 2 multiplied by 3. Those are my primes, which is also equal to 2 squared multiplied by 3. Done! Look at that. Here we go. Example 5 says, use a table. I'm not going to use the table. I'm going to use for both of these a tree diagram. If you want to know how to use the table, you could use, or you know how to use the table, you could use the table. But I'm just going to use the tree diagram, and I'm going to use it for this one here. Okay? So number 5, first of all, look at this. It's even. I know that can be divided by 2. So I'm going to divide it by 2. And I'm going to be left with 1,386, I believe. Yep. Okay? Now this here can be divided by 2 again. Okay? It's going to be left me with 693. Now I could add this up. This is 12 and 9 is 21. I know 693 could be divided by 3. So I divide everything by 3. It's going to give me a 3, 1, 3, 231. Now 231, I know could be divided by 3 as well. So 3, 77. And this is going to be 7 by 11. There we go. We are done. And there's my prime factorization. These are my primes. So what is this equal to? 2 multiplied by 2, multiplied by 3, multiplied by 3, multiplied by 7, multiplied by 11. Just our primes. We're good to go. That's how we use the tree diagram. And I'm going to be using it throughout this lesson to help us solve some questions. Now, can we remember what is greatest common factor? Greatest common factor. Now, well, factor means it divides something. Greatest is the biggest, so the biggest. We'll talk about me, where it's greatest common factor. And then common means it has to be the same. So it is the biggest number that divides 2 numbers. That's our greatest common factor. Okay? So state the greatest common factor for the following. Now whenever I do greatest common factor, I make nice little Venn diagrams. So let's make my Venn diagrams. There we go. So this is for 15, 25, and 35. And then I factor each of these. So I have 3, 5, 5, 5, 7, and 5. Okay? They're into their prime factors. Now, let's see. What's 15? Has a 3. There's no 3 in the other ones. It has a 5. Well, there's a 5 in this one, and a 5 in that one. So 5 goes away. Now we're left with a 5 for 25. It's not shared. And a 7 for 35. It's not shared. So, my greatest common factor is equal to 5. It's always the number in the middle. Okay? That's how this Venn diagram is so nice for organizing. You'll see as we get into more complicated ones, it's great to have to help you organize. Let's take a look at this next one, 18 and 20. Okay, so we have 2 and 9, 3 and 3. I always first, whenever I'm finding greatest common factor, first thing I do is I find my prime factors, all prime factors. So this one's going to be 4 and 5, 2 and 2. So I found all prime factors. Now let's check this out. There's my Venn diagram. We have 18 and we have 20. Well, 2. Is there 2 here? Yes. That goes in the middle. 3. Is there 3 here? No. There's 3 there. 3. Is there 3 there? No. Now here we have 2. No 2. And then we have a 5. So it's only going to be 2. 2 is my greatest common factor. Let's take a look at my next one. 36 and 54. So once again, Venn diagram, there's 2 of them. We're looking at 36 and 54. So next part, let's make my prime factors. Factor tree for prime factors. This is going to be 6 by 6. 2 and 3. This here is 2 by 3. That one's done. 54 is the same as 9 by 6. Okay? We have 3 by 3. 2 by 3. So let's circle. We have these. These are all my prime factors. And let's see which go where. 6 and 50. Okay, now let's see. We have 2 here. Is there 2 in this one? Yes. So that goes in the middle. 3. Do I have a 3 here? Yes. We'll go in the middle as well. 2. Is there another 2? No, there's no other 2. 3. Yes, there's a 3. 3 in the middle. Well, there's only 3 left there. We're done. So there is my Venn diagram. Now what's in the middle? We have 2 times 3 times 3, which gives me 18 is my greatest common factor. All right? Now, I have some tricky ones. Just like Run DMC would say, they're tricky, these ones. So we have 90 and 225. Well, first step always is find my prime factors. Okay? So we have 9 and 10. 3, 3, 2, 5. 225, I know, is 15 squared. So 15 and 15. I have 3 and 5, 3 and 5. Now we have my two circles, Venn diagrams. Let's see. 3. Is there 3 on this side? Yes. So 3 in the middle. Okay? 3. Another 3. 3 in the middle. 2. There's no 2 there. 5. There's a 5 on this side, so 5 in the middle. And there's left with a 5 there. So what is my greatest common factor? It's equal to 3 multiplied by 3 multiplied by 5, which is equal to 45. That's it. Simple. Next one. It's a little bit more tricky again. Same idea. What are we going to do? Looks tough, looks complicated. Factor tree. So I look at this, I know it can be divided by 2. We have 2 and 154 is going to be 77. Okay? This is going to be 7 and 11. This is going to be 2 and 99. 9 and 11. It's very good to be good at the multiplication table. So now we have all my prime factors. Now let's try and put them in. So I have 2 and 2. Done. Goes in the middle. 7 and, oh, there's nothing else. 11 and 11. 9 is on the side. Ooh, I forgot this one. This is 3 and 3. I should have done that one. Okay, I didn't quite go all the way to prime. So my answer for this one is 2 times 11, which is 22. Okay? Because it's what's in the middle. We multiply everything in the middle together. All right. Now, here are some new toughies. A real good brain workout for you for greatest common factor. Okay? We have 245, 315, and 770. First step, these are big numbers. Let's try and find our prime factorization. I know this can be divided by 5. So I'm going to put a 5 there. So what's 245 divided by 5? I get 49. So this is going to give me 7 and 7. Now we want 315. I know that could be divided by 5. Actually, that could be divided by 3. That's even easier. But we know it can be divided by 5. I get 63. It's going to give me 7 and 9. 3 and 3. Okay? Now, 770. That's 7 multiplied by 1, 10. So we're going to get 11 by 10. 2 and 5. So let's put this into my Venn diagram. We have 3. So it's 1, 2, 3. There we go. Okay? So we have 47. Is there a 7 in everyone? 7. 7. Yes. 7 shared by all 3. Oh, let's go this way. We have 245, 315, and 7, 7. Okay? Now, 7 again. No other 7s. 245. 5, 5, and 5. Good. So 5 is shared. Now let's see if there's another one. 3. No other 3s. So this is with 315. Okay, now this one has 11. 11 is not shared anywhere else. And 2 isn't shared anywhere else. So what's in the middle? 7 times 5. That's it. Now my next one is a very tough one. This one's going to make your brain hurt. All right, so we look first. So we look at this. Now we're going to have 171. We know it can be divided by 3. Well, I know 3 times 6 is 18, and we're 9 short of 180, so that's going to be 57. So 3 groups of 3 short of 60. Now this is going to be the same as 57, the same as 19 multiplied by 3. Okay, let's try 285. 285 can be divided by 5. Let's see what 285 divided by 5 is. Oh, I get 57. This is the same as 19 and 3. Let's try 399. Okay, 399. I know that could be divided by 3. Because when we add up, it's 12, which gives me 133. Okay, now 133, I look at that. That could be divided by, Now that could be divided by 7. It's going to give me 19. There we go. Okay. Let's take a look at my next one. I know this could be divided by 2. That's going to give me a total of So let's look at this next one here. This one here can be divided by 2, which is going to give me a total of 570. Okay, what else can this be divided by? Now this can be divided by 10. This is going to give me 57, which is 3 and 9. 19, sorry. So now, let's make the Venn diagram for this. Or let's just look at everything that's similar. It's hard to do quadruple Venn diagram. So we have a 19 in all of them. So there's 19. 3 in all of them. Times 3. Is there anything else? This one has a 3. None of the rest have a 3. And that's it. So it's 19 by 3, which is equal to 57, is equal to the greatest common factor. Okay? So that one there was a real toughie. Now let's look at lowest common multiple. So what is the lowest common multiple? So, or least common multiple. Well, the lowest. So we want a small number. Common, and multiple means, well, there's more than one, so it has to be bigger than our composite number, but we want the lowest common multiple. So here's some examples of what we want, okay? So 5 and 7 has to be bigger than both or equal to both 5 and 7. What's the lowest common multiple? So we have to multiply them by something. That's just going to be 5 multiplied by 7, which is equal to 35. Next one is 10, 15, and 20. Now this one here looks a bit more complicated, so I'm going to use a Venn diagram once again. We'll see how a Venn diagram works very nicely for this one. Okay, so we have here 2 and 5, 3 and 5, 4 and 5, 2 and 2. So let's see what is shared. This is 10, 15, 20. I have a 2 here. Well, 2 is only shared there, so it's only shared there, okay? Now 5, 5, and 5. 5 is shared among all. Then I have a 3 here and another 3. So the 3 is there. Then I have a 2 here, the 2 goes there. Okay? So I look at this, I have altogether 2 times 2 times 3 multiplied by 5. Okay? So that's going to give me 15 multiplied by 4, which is 60. So first thing I always do still is I find my prime factors. Then I put them in the Venn diagram. Then, once I have my Venn diagram, I multiply everything in the Venn diagram together. Okay? So this gets rid of all of our repeated multiplication. So there's no repeated multiplication in this Venn diagram. Now we're going on to a little bit trickier ones. We want 15 and 35. How do I do this one? Okay? Once again, we're going to do a Venn diagram. Okay, we multiply everything together. So 15 and 35. We have 3, 5, 7, and 5. So we have a 3, and we have a 7, and 5 is shared. So that's 3 times 5 multiplied by 7, which gives me 105. Let's try the next one. 126 and 441. 126 can be divided by 2, which is going to give me 63, which is 7, 9, 3, and 3. I look at this here. This is 8, 9. I know this can be divided by 9. So it's 441 divided by 9. Will give me 49. Okay? 49 is 7 by 7. This is 3 by 3. So let's circle all my primes so we don't get lost on what's prime and what's not. And let's cancel them off as we put them into a Venn diagram. So we look at every prime. I have 2. 2 is not shared. I have a 7. 7 is shared, so it goes in the middle. 3. Well, the 3 is shared. I have another 3. That 3 is shared as well. And then we have a 7 left over on this side. So I multiply that all together. I'm going to have 2 multiplied by 3, multiplied by 3, multiplied by 7, multiplied by 7, which is going to end up giving me 49 multiplied by 18. So let's put that in. 49 multiplied by 18 is equal to 882. There we go. Now we have a triple tricky one. Okay? So 22 is 2 and 11. First, always prime factorization. 154, I look at this, that is 9, 10, oh, we could divide it by 2, and that's going to give me a total of 77. Okay? Now this is 7 and 11. 198 is the same as 2 and 99, which is 11 and 9. 3 and 3. Circle everything up here. Okay. Now, let's see. We have 1, 2, 3. So I look at this, and I look first at 2's. How many 2's do we have in all this? 2, 2. So there's a 2 shared in each one. Now I'm going to look at how many 11's. 11 is shared in every one. Okay, now my next one. Well, we have a 7 in this one. So that's 154. Has a 7 that's not shared. And this one here has 2 3's. So we multiply this all together. I'm going to have 2 multiplied by 7 multiplied by 11 multiplied by 3 multiplied by 3. And I multiply all of that out. And I'm going to get 1,386, I believe. So now I want you to think about, how does prime factors help us with perfect squares? Well, if we look at it, if a number is a perfect square, that means it's multiplied by 2 of the same things. So if it has 2 of the same factors, it is a square number. Okay? So that's how we find perfect squares. It must have 2 of the same factors. So then, that helps us find perfect squares. So let's take a look at this here. If I look at this number, I'm going to see if it's a perfect square. First thing I'm going to do is figure out what are its prime factors. So I know it can be divided by 5. So if I go 1, 2, 5, 1, 2, 2, 5, and I divide that by 5, I'm going to end up getting 245. Now I know this could be divided by 5. That's going to give me 49. Here we're going to get 7 and 7. I combine these together. I go 5. We have one pair of 5s, and then I have a pair of 7s, which gives me 35. Done. Okay? Easy. So the square root, this is 35 multiplied by 35. So this is a perfect square. Let's take a look at this next one, 3,042. Well, let's start my prime factorization. I can divide both by 2. So we go 3042, and we divide that by 2. We want to get 1521. Okay? 3 and 6 is 9, so I know that could be divided by 9. I'm going to go divide that by 9. I'm going to get 169. Now, this is 13 multiplied by 13. And this here is 3 multiplied by 3. Here are my primes. Now, looking at this, I have a group of 3's. I have a group of 13's. But this 2 doesn't have a partner. So therefore, this is not a perfect square. Now, my next one is we're going to look at cubes. So right here, it's hard to tell, but I have a picture of the cube, which is a perfect cube. Now we have 2, 1, 6. I know this could be divided by 6. And that's going to give me 36. We have 6 and 6. Once again, we use the factor tree to get our prime factors. I have 1, 2, 3 6's. So that's the same as 6 multiplied by 6 multiplied by 6. So yes, that is a perfect cube. For a perfect cube, we need 3 of a kind. Let's see if this is a perfect cube. I look at that, I could divide that by 5. So we go 3, 3, 7, 5, divide by 5. I'm going to get 675. Now I can divide this by 5. And I'm going to get 135. Okay, divide 135 by 5, and I'm going to get 27. And 7 is 3 by 9, which is 3 by 3. So I look at this, I have 1, 2, 3 5s. And I have 1, 2, 3 3s. So this is the same as 15 to the power of 3. So this is a perfect cube as well. And that's how we do those. So hopefully you understood everything. If you have any questions, please ask. And if you have anything that you want to know more about or you want to take this in farther, please ask me tomorrow in class. Good luck. See you tomorrow.